When we are considering routing implementation, we have to think about the layer 2 network that we're running on top of. That's a big deal because dynamic routing protocols behave differently with respect to the network that they're running on top of. Now, most work beautifully. I'm going to say all work beautifully in a broadcast environment. When it says broadcast, we're talking about the layer 2 capability of sending to a single address and have that go to every device in the network. So how do we broadcast in a LAN? Let's say Ethernet. How do we broadcast on Ethernet? We send to Fs. Got the right number of addresses there. That's how we broadcast. And that fans to everyone on the network. Okay. Non-broadcast multi-access lacks the ability to broadcast. It's implied in the name. It's said in the name. Non-broadcast. So what we have to do is we have to string out the communication and use unicast to simulate broadcast. So if I have to communicate to 3 different neighbors a routing update, let's say I have a link state update that indicates that a network just came back up. Let's say it's good. Well, we want to get that to all the other routers. In a non-broadcast multi-access network, I can't send that with one update. I have to send that and repeat it. And that's what's going to be done here. It's going to be repeated to the other devices. OSPF is a little bit challenging on non-broadcast multi-access, and don't mistake me when I say challenging. It works, but you have to know how it works. And so if you ever take the time to apply OSPF to NBMA topologies, you have to do some extra work to build in the neighborships that are going to allow you to convey those updates. Point-to-point. Now this is one that's also interesting. Routing protocols love the simplicity of point-to-point. And if you were to build, like, let's say a frame relay network, not like you're building frame relay networks every day because it's kind of an older technology. We used to have a choice of going with one or all your PVCs on the same subnet, which would look a little bit more like this, or simulating a lot of point-to-point networks. And we would always choose point-to-point. We love the simplicity. But here's what's impactful. Different routing protocols behave differently in different contexts, right? Well, the big one on point-to-point is, now, we may not have talked to you about OSPF designated routers, but on point-to-point, we have no OSPF DRs. So that's the sort of thing that we have to be mindful of. That's why it's important, is because we get little alterations in the behavior of our dynamic routing protocols when they're running on different network types.